In this problem, we have three vectors shown in this diagram pointing in different directions, and we want to find the results of two vector sums. Now the process for adding vectors is pretty simple, but also kind of repetitive. The common method is to break down all the vectors into different components, into their x and y coordinates, and then add them up individually that way. That works pretty nicely, and I like to make a little table here to keep track of everything, but it can also take a while. So to keep this video simple, keep it from being too long, to save both your time and mine, I'm going to go over the basic formulas that you'll need to use, and then show the results of those calculations. So you can check them with your numbers or check them with these numbers to make sure you're doing the right thing. So first off, the formulas you need to use to figure out the x and y coordinates are the trig functions. So if we have some vector r, then the x component is equal to the magnitude of r times the cosine of the angle. For the y component, it is equal to the magnitude of the vector times the sine of the angle. So we can just use these two formulas to find the x and y components for all three vectors. Make sure your calculator is in degree modes, and you find that for the x component of a, that's 38.85. For the y component of a, that's 20.66. For the x component of b, that's negative 14.82. For the y component of b, that's 21.97. And c points entirely in the negative y direction. So the x component is 0, and the y component is negative 31.0. Now that we have the components, we can find the vector sums. Let's start with b minus 3a. So we take this expression with both the x components and the y components separately. For b minus 3a in the x direction, this is negative 131.37. For b minus 3a in the y direction, this is negative 40.01. There are two more equations I want to write out in this little space here that we're going to use for the next few calculations. First of all, the magnitude of a vector is solved like the Pythagorean theorem, where we take the square root of the sum of the square of both components. The angle that the vector is at is equal to the arctangent of the y component divided by the x component. Using these formulas on the two numbers we've just found, we find that the magnitude of this is equal to about 137. And if we use the angle, the theta formula, then we get an angle of about 16.9 degrees. And since both components of the vector sum are in the third quadrant, that means that this angle is 16.9 degrees below the negative x-axis. So that is our magnitude and direction for the first vector. For the next sum, we want to find 2a minus 3b plus 2c. We will use the exact same process. The x component of this sum is 122.16, and the y component of this sum is negative 86.59. Putting these x and y components together, using these two formulas that we described here, we find a magnitude of about 149.7 and an angle of 35.3 degrees. And your calculator will probably give you this with a negative sign, because as we can see, this component's positive and the y component's negative, which means that this vector will be in the fourth quadrant, meaning that this angle is actually 35.3 degrees below the positive x-axis. So that's the magnitude and direction for the second vector sum given to us by the problem. That's all for this video. I hope it helped you out. If it did, please consider subscribing, since that'll help me make future videos. If you have any questions, please leave a comment down below and I'll do my best to help and answer any questions. If you have further questions, I have a Discord server linked in the description where all are welcome to join and ask whatever they want. That's all for now, and I hope you have a lovely night. Bye-bye.